Interesting. After you did that, what did you do? No commitment. You were talking a minute ago. Were you just talking about what you had for lunch, or did you talk about some physics? Physics? Jordan, where did your conversation start out? You listed all the givens. That's a good plan. You did, yeah. Okay, so like if we do that, let's write that out. dx, vx, ax, dy. Have a great day. We'll see you soon. Oh, it's frozen, so you can't see all the brilliant stuff that I'm writing. I'm writing down the answer for you. No, I'm not really. Really just writing this out. Mira pointed out that they're launched from a little bit above the ground, right? Let's assume that that's h equals, like that the displacement's going to be 0 in the y direction. It's going to be a little bit off, but for our purposes, it's okay. So let's call dy 0. Let's call ay negative 9.8. Let's call ax 0. It tells you vx, right? And you could figure out vy. I'm just going to go ahead and write down the vx's. So vx is given. Vy is like this part. Does that make sense to everybody? So that's going to be the initial velocity times the sine of theta. I'm not actually going to do the math, but I just want you to see where that's coming from. And we want to rank the dx's, right? So that's really our goal, is to rank the dx's. What things go into dx? What things are relevant when you're talking about dx? How would one calculate dx? You've done this a few times. What's the big fun equation? There is a 1/2 in it, yeah.
Vi times t plus 1/2 at squared.
Uh-huh.
But we never had an equation. We don't know. The 2t's, right?
Right. So here's the thing, ladies and gentlemen. I'm not asking you to actually do the math for this. Like, you can. That would be a lot for extra problems. You can, or we can think about this kind of in a big picture way, which is really, as a physicist, what I'm trying to get you to think about. It's not just a plug and chug, do it. It's a let's think about it. So we're trying to figure out dx, right? So that depends on vxt and ay. How do the ay's compare for those four situations? Or that's supposed to be x. You guys, you got to talk to me. You got to be like, Carboline, what are you talking about? It should be an x, right? Sorry. What's ax for this one? Ax for this one?
0.
Ax for this one?
0.
Ax for this one. Okay, so 0 for all of them, so let's get rid of it, eh? Does that sound good? Catch you later. See you later. Okay, life is good. So now, dx equals vxt, yeah? How do the vx's for the four of them compare? They're all the same, right? So all the vx's are the same. So what is it that's going to dictate dx? The time. So far, so good? How do the times compare? Are they all the same? How, if you were going to do this problem, it's all kind of a hypothetical, right? If you were going to do this problem, and I gave you this, and I gave you this, and I asked you to find dx, like on a homework question, how are you going to find dx? What do you have to do first? You have to do the y stuff first, don't you? So let's look at that. The y stuff says dy equals vyt plus 1/2 ayt squared. Does that make sense to everybody? dy is 0. T is really dependent on what? Does ay change for any of these? It's all the same. Is vy the same for all of them? It's not. So here's the big picture physics concept that I want to tell you, and then I'm going to let you keep working. Using this y equation, you could find time. I'm not going to make you, but you could, right? One could do it. To find time, you would need to look at the Vy. The bigger the Vy, the bigger the time. Does that make sense? Let me say that again. The bigger the Vy, the bigger the time. You with me there? If I release it with a higher velocity, it's going to take longer to come down. The bigger the Vy, the bigger the time, the bigger the time, the bigger the dx. Because in the x direction, they're all moving at the same rate. But we want to know who gets to go the longest, who gets to go the furthest, based on how much time we have. Are we doing okay? Okay, so I'm going to write that down. So Vy determines the time, and time determines the dx. I'm going to give you a couple more minutes to work, okay? I think you can do this, ladies and gentlemen. In fact, I know you can do it. Give it a try.